let us evaluate the integral of tan to the power 5 of x. And so, when dealing with either a tangent or a secant, first up, you must factor out 1 tangent squared of x or 1 secant squared of x. So, since what we're dealing with here is tan, so let's factor out 1. So, this should be the integral of tangent squared of x multiplied by tangent cube of x dx. And so, the reason that we factor out 1 tangent squared of x here is because we're going to use the trigonometric identity for this. So, know that secant squared of x is equal to 1 plus tangent squared of x. And so, since what we want here is tangent squared of x, we must transpose 1 to the other side, which makes this equal to secant squared of x minus 1. And so, replace tangent squared of x with this. So, this would be the integral of secant squared of x minus 1 multiplied by tangent cube of x dx. And so, next step would be to distribute tangent cube. And now, for simplification, we must split this integral into 2 parts. And so the first part would be the integral of secant squared of x tangent cube of x dx minus the integral of tangent cube of x dx. Let us focus on this first part. And so, let u here be tangent of x. Know that when using u substitution on a variable, know that when you take its derivative, make sure that it cancels out the other variable that is in them. So, let u here be tangent of x, because you know that the derivative of tangent of x is equal to secant squared of x dx. And so, take the value of dx, which is equal to du over secant squared of x. So, by replacing that, this would be the integral of secant squared of x. Tangent x here is equal to u. So, this would be u. And since this is raised to the power of 3, and so multiply it by the value of dx, which is equal to du over secant squared of x. And so you can actually see here, secant squared x will cancel, leaving you with integral of u to the power of 3 of du. And so, taking the integral of this would be u to the power of 4 over 4. But we don't need to add yet plus c, because remember we have the other part of the integral. And so, by putting u back into its original form, this would be 1/4 tangent to the power of 4x. So, this would be the answer for this first part of the integral. And now, let's focus on the second part, the integral of tangent cube of x. And so, notice here that it is the same as the problem earlier, just with a different exponent. So, let's use the same rule that we had applied here. So, once again, factor out 1 tangent squared of x. And so, replace tangent squared of x with secant squared x minus 1. And so, distribute tangent of x. And now you can see here, we must split this integral again into 2 parts. And so this would be the integral of secant squared x tangent x dx minus integral of tangent x dx. Now that we have this, so focus on this part again, the integral of secant squared x tangent x dx. And so you can actually see here, it has the same problem as this earlier. So just substitute tangent x as u here, and so take the derivative and find dx. So if you substitute it, this would be the integral of secant squared x multiplied by tangent of x, which is u, and multiply it by dx, which is du over secant squared x. And so you can see here again, secant squared x will cancel, leaving you with an integral of u du. And so, taking the derivative of u du based on the power rule, it is simply u squared over 2. And so, replacing the integral of this, so this would be u squared over 2, or 1/2 u squared, or the u value here is tangent of x, so this would be tangent squared of x. And now, focus on this last part, the integral of tangent of x dx. So how to get this its integral? Since we cannot factor out tangent squared x here, let's use its identity. Know that tangent of x is equal to sine of x over cosine of x. So this would be the integral of negative integral, of sine of x over cosine of x dx. And so let u here be cosine of x. And so take its derivative, which is equal to negative sine of x dx. And so taking dx, this would be du over negative sine of x. So substituting that, this would be negative integral of sine x over cosine of x is u, multiplied by dx, which is du over negative sine of x. You can see here, sine of x will cancel, and now you are left with a negative sign here, so you can put it outside the integral. And so since it already has a negative here, this would be a positive integral, and so you are left with the integral of du over u. And so based on the logarithmic formula here, the integral of du over u is simply the natural log of absolute value of u plus c. Know that the original formula would be the integral of dx over x. This would be equal to natural log of absolute value of x plus c. And so, now that we have our answer for the integral of tangent of x, not exactly the final answer because you need to put u back into its original form, and so the answer here would be ln of u here is cosine of x plus c. And so, now that we have our answer here, the final step would be to simply just combine it all. And so, your final answer here would be 1/4 tangent to the power 4x, and distribute negative sign upon these two. So this would be negative 1/2 tangent squared of x minus the natural log of absolute value of cosine of x plus c. By the way, just a disclaimer, plus c here is not affected by any negative. Just put plus c.